Hi. So I'm not really sure how easy it is to follow some of the walkthroughs I did of the geometry nodes, so I thought I'd make a step-by-step video here. So I take the cube and rename it, and then copy it, and then one's going to be named Ping and the other's going to be named Pong. And here I'm trying to turn on the screencast so you can see what I'm doing, just in case that helps anybody. So you give each geometry nodes setup. So here I'm renaming with the F2 key, Pong, and then Ping. And give each geometry node setup. So in the Pong, you drag over the Ping object, and then you connect the object, and then take the geometry out of that and put it into the output. And then over here in the group, add 3 groups. One's going to be new, which is the angle that's propagated through the geometry node setup and changed as a function of the delta t that you give it. And then there's r cosine new and r sine new, which are just position components of a position vector. And then all you have to do is connect to those, and then the Pong is done. All you're doing there is just passing these variables through the Pong and then back into the Ping in the next iteration when you run an animation. And then you need to make sure over here in the panel that you have new. Here I'm just typing them in because they're not showing up. Sometimes they show up and sometimes they don't. Not really sure what I'm doing to make them appear and when they do, but just type them in. And so Pong is done. And now we go to Ping, and first thing we're going to do there is drag the Pong over. And then connect the geometry to the output, and then the object to the input. And here we're going to start with an icosphere. And then I'm looking for the scene time, and we're going to use the frame as the switch input. You need to change it to integer, put the frame in there, change b to 1, and then you can take this into a switch. And here, if it's frame 1, then we want to use this icosphere, so put that into true. And if it's false, we're going to take this geometry from the object and use that as the object, the geometry. And this is another switch that we're going to use that same trigger for. And if it's false, oh, well, I don't have the inputs and outputs yet, so let me do that. So same 3, new, r cosine new, r sine new, and do that both for the input and output. So after we do that, if it's true, we want to put that into a value node. And if you just drag the noodle and drop it, it's going to automatically pop up a menu where you can start typing what you want and then choose from the list that comes out of that. So that one new is going into if it's false, and that's the new that's being changed each iteration. If it's the first frame, then we're going to put in the default new at 0, which is 0 for our case. You can change it to anything. And then we're going to take the cosine of new and multiply that by E. So we're going to hit F2 and change this to E, and our eccentricity is going to be 0.6 here. And then I need another parameter, which is P, and this all goes into the calculation of the radial distance from one focal point of the ellipse for the orbit out to the satellite that's orbiting the main object. So then I add 1 to that, and then divide P by the 1 plus E times cosine nu. So when I divide P by 1 plus E times cosine nu, that's R. And then I'm taking it to the power of 2 for another calculation, and here dt, I'm using 1 over 24. There's by default 24 increments per second in Blender, and h is the angular velocity, so I'm taking dt, dividing by 2, and then multiplying that by h. And so that should be dA. So if I change that, that's dA. And then the next equation for that is if I multiply that by 2, and I know it's kind of silly to divide by 2 and then multiply by 2, but I'm sticking to the equations that you'll probably find if you look this stuff up. And then I'm dividing by that, r to the power of 2. And this should be d nu, which is the incremental change in nu, which is the angle that the satellite sweeps out as it rotates around the main body. And here it's assumed that the satellite is a mass that's much smaller than the main body, which is at one of the focal points. So here I'm taking nu, the old nu, and here if you hit shift and then right mouse swipe across it, you get a little node there. That's if you turn on the node wrangler add-on. And then I'm adding that to the delta nu and then putting it into a capture attribute so that I can put that into the output. So whatever's coming out of that switch goes into the geometry, and that goes into the output geometry, and now you can see, oh, there's the icosphere. Let's see, next, let's take this nu, and we're going to start calculating positions and put it into a cosine. And then we'll copy that and drag it over, and this time we'll change it to a sine. And then we're going to multiply this by r. And that's the positions, the x and y positions relative to where the main body is in this little orbital system. So I'm putting those into a combine x, y, z. And what I'm also going to want to do is take the positions that we're feeding through the system here. It might be easier if I grab another group input. Sometimes it gets a little messy with all the lines going between the nodes. And then what I want to do, I want to subtract these two. So the set position, the offset is relative to where it currently is. So we want to take the new position, subtract the old position, and then we just get a change. And that goes into a set position here. So I'm going to put the geometry through this set position and then copy this capture attribute a couple times. And here's where we're going to get the R cosine nu and R sine nu calculations that are going to be fed through the system. So there's the R cosine nu, and there's the R sine nu, and then so nu is going into there, cosine sine times R. Then I need to make all the connections here to the group output. I'm moving things around a little to make it easier to see, hopefully. If I zoom out, you can see it's at a starting position. And this is all based on the R calculation. Oh, it's not really behaving as I thought. And what's happening there is I forgot to put the variables here in the geometry nodes panel. And here I'm just typing them in. And then do the same for the outputs. Now if I reset it, hey, there it goes. And you'll notice there's two. If I zoom in, and that's because over here, both the ping and the pong are being plotted. But what I really want to do is just plot the ping. The pong is there, but it's offset by 1 time increment. So that's why 2 are rotating around. And here I'm adding a subdivision surface to the icosphere to make it nice and smooth. And then if I reset it, let's see, reposition a little, and then set the simulation in motion, and you can see it's kind of doing what you'd expect. It's sweeping out equal angles in equal time as it gets further away from the focal point, which is the origin here. It gets slower, and as it gets closer to that, it gets faster. And here I've rotated it a little bit to kind of show you what you could do. Sometimes, if you look at like images of the solar system, like sometimes they're in kind of close to the same plane, but sometimes there's ones that are off at an angle. So, what you could do is you could have one that this highly eccentric satellite about the main body, and then you can put that put the ping and the pong in a collection, and then copy that collection. And then, of course, go in and make sure that you duplicate the geometry node so it makes a copy of it. It looks like if you do it over there in the panel, that doesn't work. You got to do it over here in the geometry nodes portion. And then it knows it's separate. It's the same node setup, just a separate one. That's kind of odd. So here, this one's not rotated, so I have 2 that are basically doing the same thing. So let me change some of the parameters. For E, make it less eccentric, and then I'm going to have to turn off the pong on the other object that I have here. And let me change the rotation of that system. So now I have 2 rotating around, and I changed the P to 10, E to 0.2, and now I have one that's more of a circular orbit around the main body, and then one that's in this eccentric orbit. So that's about it. If you have any questions about it, go ahead and shoot a comment, and kind of neat. So yeah, please like or subscribe if you like it. If you prefer step-by-step stuff, let me know. If you like the walkthroughs better, let me know. Okay, that's it. Bye.